So good morning, I guess good afternoon to maybe many of you. Thanks for coming to this webinar. I'm going to show you some new technology we've built that lets you do slippy web maps really quickly and easily, straight from Icechunk or Zarr data in the cloud. My name is Deepak Cherian. I'm a forward engineer at Earthmover today. I have a oceanography background, and I've spent a lot of time in the open source scientific software space, working on packages like Xarray, Zarr, Icechunk, and a couple of others. That open source journey eventually led me to Earthmover because I felt that we just needed a lot more polish and professionalism around the software that was powering all of these workloads in the real world. And so I'm really excited about this webinar because putting data on a map is one of the things I wanted to do as a scientist, but it was just a little too hard and too far away. And the stuff that we've built now, I think, really fits that need that I had about 5 years ago. So the agenda, first we'll look at some maps, just kind of show you where you can go with the stuff. And then I'll introduce a new open source library called xpublish-tiles. I'll show you a very quick kind of demo of how you can kind of build this kind of demo app from scratch, or at least part of it, really easily with our technology. And then finally make a pitch for why you would use Earthmover Tiles, which is our managed offering built around this open source package known as xpublish-tiles. All right, the first one is just a really nice slippy demo map made by my co-worker, Matt Iannucci, who's also on this call. And so the link should be this dashboard. And it will take you to this little nice, cool map of the world. This is GFS, or NOAA's Global Forecast System dataset that's sitting in Arraylake, and now it's being presented on a nice little slippy map. This field is 2 meter temperature for a single timestamp. As you can tell, this is pretty simple, but if I click a button here, you'll see a time series of values at that point, and the ability to export that time series in a number of different formats. What's happening here under the hood is that the data is sitting in Icechunk, and it's being rendered as these map tiles or PNGs in this browser app. And then when you click, so that's coming through this new OGC Tiles API, which I'll talk about a bit more later. When you click, we use a different protocol known as EDR, or Environmental Data Retrieval, which basically says, give me all the data you know at this point. And so that's what's being rendered down here. And the EDR also lets you export it as many different formats. If you click over to this left sidebar, you'll see a couple of other options. So if you're looking at GFS Globe with tiles, you can click TCC. This is total cloud coverage from the HER forecast. So here again, so you can see that we can handle different projections and stuff like that. So that's very, very simple demo app, but shows what's possible. This code is open source, so you can click there to go on GitHub to look at kind of more details of what's happening behind there. So that's where we can go. What's underneath here? If you click in, you should be able to get into this Earthmover public organization. So if you have access to Arraylake, which you should be able to by just signing up, you will see this dashboard for the Earthmover public organization. We kind of show you a bunch of metrics. I'm going to click into repositories. And so here you'll see the data that's powering those web apps. So I click into GFS, which is the first app I showed you. This is a view of Icechunk or Zarr data. So GFS is a Zarr store or Icechunk store. And it has one group called Solar. There's a little automated pipeline that is populating this data every 6 hours, I guess. That's the GFS update frequency. Click into Solar. There's a bunch of variables here. So TCC, for example, is total cloud cover. You can see how we exposed a lot of the underlying Zarr metadata in this kind of web interface. Anyway, so this is just data sitting in the cloud, and it's being delivered out by a couple of services. If I click back to the dashboard, there's this services button, and you see we have 4 different protocols being served directly from that data. So DAP2 is OpenDAP or NetCDF style data serving. Tiles is sending out PNGs, which is what you saw made that globe map. WMS is very similar to Tiles, just a slightly different protocol, but same idea. You send out PNGs to help you make maps. And EDR is the one that powered the, you click the button, sorry, you click on a point and you get back a time series, right? So there's 4 different services that are running up in the cloud and serving that dashboard as we speak. And so this is a pretty cool demo of everything that we have, nearly everything that we have built so far. So the data that I showed you, powering those dashboards, are sitting in AWS. They're stored in Icechunk and managed through Arraylake, which gives you a data catalog and data governance. But then to actually use that data, you can either access it directly using Icechunk, but also maybe make your own web apps and dashboards. To do that, you need the Icechunk data served out in standard protocols, which is what we help you do using our service called Flux. And I've shown you the OGC Tiles and EDR APIs in action. We got a couple more, and we'd be happy to talk to you about that. Please reach out. And so why did we build this? It's because, and as I'm sure many of you have this need, many of our customers come to us and say, I just want my data on a map. And when they say my data, they mean a large variety of very complicated grids. So for example, a regular or rectilinear mesh is defined by like 2 one-dimensional coordinate vectors that are orthogonal. Raster affine is something that's common in the geospatial space, where things are defined by an affine transform and a uniformly spaced grid. This is the HER grid, which is a projected coordinates grid, so you can kind of see the wonky shape. Curvilinear grids that maybe follow the coastline, and more. So reduced Gaussian stuff coming out of ECMWF, and then unstructured meshes too. And handling this whole space of complexity is a little bit hard. And at Earthmover, we are pretty proud of our open source and open core leadership. We spend a lot of effort on projects like Xarray, Zarr, and most recently Icechunk. And so in that kind of vein, we've open sourced all of the cool technology underlying this in a new open source library that is known as Xpublish-tiles. You should be able to click over to this GitHub repo. Xpublish-tiles is an Xpublish plugin that helps you serve the OGC Tiles API. So there's a little bit of stuff in there. Xpublish is an existing project. It's existed for quite a while. And it's basically an easy way to connect FastAPI to Xarray. So you take an Xarray dataset, you want to serve it over HTTP with some REST API. Xpublish helps you do that really easily. The way Xpublish lets you configure which protocols you end up serving is through these plugins. So you have things like Xpublish EDR, Xpublish WMS, and now Xpublish Tiles, which serves a standard that is known as the OGC Tiles API. The idea behind the Tiles API is you take the whole globe and you cut it up into squares. And then you take each square and cut them up into smaller squares. So zoom level 0, the whole globe is 1 square. As you zoom into zoom level 1, the whole globe becomes 4, and then 8, and then so on, 16, and so on and so forth, right? And so this is kind of basically the idea underlying Google Maps, right? So as you zoom in, you end up seeing smaller and smaller pieces of the globe rendered at higher and higher resolution. This library powers the Earthmover Tile service under the hood, and it builds on a lot of open source projects like Mercantile, Datashader, PyProj, and others. When we built it, it was basically a full rewrite of an existing project known as Xpublish WMS, and we focused on making it more modular, more testing, more correctness, and a bunch of performance. Some nerdy details that I'm pretty happy about. One of the challenges that we faced with handling the wide space of customer data we have is it's very easy to have bugs because this data is just messy. Real world data is messy, and it's very easy to break your assumptions. And so one of the tricks we've used is this idea known as property testing. Of course, we should all have tests, but it's very hard to write unit tests for the whole space of weird data sets that customers come to us with. And so instead, we use this idea called property testing, which is where you generate arbitrary inputs, and you assert that the output should have a certain property. Here's an example of what that would be. Consider a global data set like the GFS forecast, right? So there is a value for every pixel on the globe. When you render that on a map, you should never see transparent pixels, right? There's always a value at any point on the globe. So that property is for a data set, no file should ever have a transparent pixel. This holds for any way you represent that data. It doesn't matter if the latitude is increasing or decreasing, if your longitude is in the -180 to 180 convention or the 0 to 360 convention. And it should also hold for arbitrary data shapes, and also many different ways of specifying a grid. Regardless of any of those details, if you try to render that data set on a map, you should never get a seam that looks like this. So this is an issue that we had in our previous WMS offering, where there was a little seam at the anti-meridian because of a bug in handling this kind of stuff. But basically, the property here says that should never happen. And this is the kind of approach that we took to making sure that this Xpublish Tiles project was correct. Second property that is also quite fun. If you have the same data that's on the simplest possible grid, right? This is the uniformly spaced grid in X and Y. There's 3 different ways, at least, of specifying that uniformly spaced grid. In the geospatial satellite imagery world, they use something known as a geotransform or an affine transform. So that's basically just a set of 6 numbers that tells you the coordinate system has a spacing of 1, has a shape of 2 by 2, and so it's got these like 4 values, right? 11, 12, 13, 14 at uniformly spaced values starting at 1. You could specify that with explicit one-dimensional coordinates. So here's the same data, 4 values, and the grid specified by 2 1D vectors, x equals 1, 2, and y equals 1, 2. And the next thing you can do is you can also specify that as 2 two-dimensional coordinate arrays. So here's 1, 2, 1, 2, and then 1, 2, 1, 2 in x and y, right? All of this is the same data. It's all in the same grid. It should always render as the same tile, regardless of which representation that you choose, right? So this is another way we ensure that we can handle all the complexity that our customers come to us with. And you can do this for any, again, it doesn't matter what your latitude or longitude conventions are, whether they're increasing, decreasing. It doesn't matter what coordinate system you're in, this property still holds, right? And so you can generate arbitrary data sets that cover that space, and then test this property to make sure you've got it right. The other thing we spent a lot of time on was being kind of clever and smart about performance. And this has kind of prompted a lot of upstream open source work. The first thing that's cool about the Tiles plugin is it provides an async endpoint that's powered by a new async data loading feature that we added to Xarray. So check that out. The other cool thing that we did was we heavily optimized the most common rendering case, which is you have the input data is in latitude, longitude, or EPSG 4326. And very commonly, you're rendering to what's called the Web Mercator projection. You can think of that as the Google Maps projection. It's kind of the default in a bunch of JavaScript libraries that are useful for rendering web maps, like Mapbox or MapLibre. And so that's basically the most common path, and we've spent a lot of time thinking about how we could do that better and faster. And so there are some tricks that I've described in this blog post that you should look at. We also reduce the amount of rendering work that to be done by basically coarsening or block averaging the data before we pass it into the renderer. You can think of this as basically generating overviews on the fly. And so what we've done here is basically put a lot of effort into making it very performant to render this data directly from Icechunk on disk without requiring any pre-processing or pre-generation of overviews or images or anything else from that data. For more, you should read this blog post. I want to emphasize that all of this work that I've just been describing now, which is fairly technically sophisticated, is all open source under the Apache 2.0 license. So you should be able to pull that down and start experimenting with it and see how well it works for you. So things that we kind of do well so far, again, no pre-computation necessary. We've tried to give you as much performance as we can, and we still have some more ideas that we can work on there. We support many different ways of specifying the grids, and we're trying to add on more. I'm currently trying to work on supporting things like the reduced Gaussian ECMWF grid, which will eventually lead to support for general triangular unstructured grids. But we do support the rectilinear, the curvilinear, and the kind of raster affine transform-based grids today, and a whole spectrum of coordinate transforms. We focused a lot on correctness to make sure that none of our users were surprised when they plot the data. Because if you plot the data and it looks weird, the first thing you're inclined to do is see if the data is bad, and that's not a good outcome. And so we spend a lot of effort trying to make sure that we render the data as it is on disk and are not messing it up. We've spent a bunch of time focusing on performance, which basically ends up being you can view your data at low zoom levels without having to do any of this pre-computation stuff that you need to do otherwise. The way most users we know do this kind of work today is that they take the data sitting in Zarr, they export it to something like GeoTIFF or a COG, which is cloud optimized GeoTIFF, and then run kind of software from that ecosystem to do kind of rendering. And so this technology that we have here really avoids all of that. You could go directly from your data in Zarr and Icechunk to these rendered map tiles. Things that we don't do yet, but plan to do eventually, are support for overviews, and as well as support for easily computing those overviews. We do not yet support things like on-the-fly dynamic calculations. You could think of that, hey, can you generate wind speed from me from the two velocity vectors components? We don't do that yet, but we could in the future. And then finally is things like RGB compositing that might be useful with like satellite imagery. Things we don't do yet, but the library is open source. So if these are things that are useful for you, please reach out. We'd be happy to collaborate. Okay, so here's the demo. If you're an Arraylake user, here's how you would make your own slippy map. I'm going to click over. Again, you're just going to go to the Earthmover public organization. Let me go to this slide. So there's going to be 5 steps here, and I'm going to walk through them in sequence, and then we'll come back to this slide. And so if you're an Arraylake user and you have admin privileges, you should be able to go to this services page, and you see I right now have all 4 of them up, but here's how you would add a new one. You would simply click Add Service. You could say OGC Tiles. You could make it publicly accessible or not. We let you create API tokens that let you control access to this kind of data serving. And so the service is already running, but if it wasn't, I would just click Add, and that would spin it up in the cloud. You don't have to worry about anything. We handle all of that complexity there, and we handle everything around the authentication. On the authentication note, I could go to API clients, create a new token here, and say, hey, this token can only read repos at Flux. It cannot do anything else. So we give you all of that. But now that service is running, so the next thing I would do is go find some data to render. Go to GFS, let's pick it. Go to Solar, that's the group with a bunch of data. And then over here is this very cool data access tab. Click over to that, it will do, it's like, hey, here's the URL that you need to serve your data over OpenDAP, for example, the EDR query, and then the map tiles query, which is what we care about today. I'm going to pick the web Mercator quad tile matrix set. So that's the most common Google Maps projection. Variables, there's 5 of them. I'm going to pick Gust because I remember what the color scale should be. For this one, I'm going to pick 0 to 40. I think the units are meter per second. For a color map, let's see, we can pick, I forget which one I picked. Does anyone have a preference? I could go with Jet. Let's do Inferno. And then you need to pick like a subset of the data. I'm just going to pick the latest time step and then say, let's take the analysis step, not the most future forecast. So this gives you this complex URL, which is what you would need for making the app. The next thing that you do is there's a bunch of boilerplate code. So we've enabled the tile service. We use the data access tab. This gives you a URL that you can hit to get that image. I forgot to show you this one cool thing. We can make sure that stuff looks like what you expect using the preview. And so here's some very pretty map already rendered for you. You can click show code here. This is a bunch of basically boilerplate that can go in. And the URL that we've created is specified here. So there's this one line that basically changes depending on how you want to tweak your image. Your color map, your color scale range, or variables, or time steps, et cetera, et cetera. What I'm going to do now is share a different window. So this is just my text editor, which is Emacs. It will show you nothing. I'm going to copy paste all of that code here. I'll save it. So again, like I said, this is a lot of boilerplate up here. And the one thing that's special to the data set is this little URL, right? So it says, take the Earthmover public organization, take the GFS repo, take the Solar group, hit the tiles endpoint, give me tiles in the web Mercator system, for the variable name Gust in the color scale range 0 through 40. Style raster just says, hey, give me PNGs. and then Inferno is the color map, this size, etc., right? And so you have that. I'm now going to go back and share my browser. And I had this up earlier, so if I go look for slippy.html, so this is just a local file. It should come up. So that's how easy it is, right? You click, someone deploys the service, you click into this data access tab, and we make it really easy for you to set up this kind of special URL that you need to provide to the JavaScript framework. You can either use the demo MapLibre app that's on our documentation page, or you can click the little preview thing, make sure that you got it right, and then copy the code that's shown down here. All I did was put that code in a little HTML file, and boom, here's the map. And you can kind of scroll in, and we'll re-render back to it. The data is pretty coarse, so scrolling in doesn't really do much. But if you had a higher resolution data set, you would see great stuff. So all of that is kind of Earthmover stuff. The core technology, as I said, was open sourced under this project called Xpublish-tiles. It includes a little CLI, mostly built with Cloud Code, which was a lot of fun. That lets you serve even local Zarr or Icechunk datasets that are on your local disk, or even datasets that are part of the Xarray example gallery. And so you can run basically an equivalent version of this locally, and it's what we use to develop the whole thing, so it's very functional. And so a question that you might have is, why would you use Earthmover Tile Service when a lot of the core technology is indeed open source? And so the idea here is that we provide you a fully managed service that enables tile serving with the click of a button, like I showed you. So add the tile service and it's up. You have no infrastructure to manage. We will do that for you. It integrates pretty tightly with the data catalog. I showed you how you can use a little web app to kind of create the URLs that you need for your JavaScript framework, kind of iterate on things like the color scale range or the color map to make sure it looks exactly like you want before you move to HTML land. It also has cool auto-scaling behavior that can support high load. So if you were using the service to, say, serve a dashboard to your downstream customers, we can handle that load for you. We've also built in a lot of enterprise-grade features like authentication, authorization. I showed you how you might create like a little API token that would just give you access to say a particular repo with read-only access to those Flux APIs. So they can't even access the underlying data. They can only see those protocols that you enable. We give you logging and metrics and a bunch of sophisticated caching that's pretty tightly integrated with Icechunk under the hood. And so that's it. The kind of rough overview here is we built a new packaged open source package called Xpublish Tiles, and then a managed service offering we're calling Earthmover Tiles on top of that. That lets you take Icechunk and Zarr data sitting in the cloud and serve it out to Slippy maps. And that's kind of just one component of things that you need to build a more fully featured dashboard. And yeah, it's pretty cool. I'm happy to take any questions. Thank you.
So Deepak, you have one question from Drew in the Q&A.
Actually, I think it's answered now. Since I saw the docs, it does seem like it recommends following CF conventions on the data set.
Yeah. Yes, we try to be clever and do a bunch of auto guessing, but it is always better if you annotate your data set properly. Any other questions? Do people think this is cool and like solves a need you've really had? I know it does for me. But yeah, if you have questions, reach out. We'd be happy to work with you guys on the open source project too. And also, of course, absolutely happy to talk to you about how you would use this for your data set. Do you have a sense of how the performance compares to the previous WMS service? Yes, it is a lot better. It can become even better, but the short answer is it is a lot better. And the blog post talks about a lot of the tricks that we've used to make it better. What EDR query types are supported? This is from Shane Mill, position, cube, etc. So we support a whole bunch of them. I'm going to go over to this cool data access tab, click EDR, and you see we support position, area, and cube. So yeah. Do you have an example showing performance on higher resolution datasets with the on-the-fly overlays? Ooh, not handy at the moment. I'm trying to think. Oh, maybe, okay, I'm gonna try. Okay, I did not practice this bit, so it may or may not work, but we will find out. You have this little data cube that is, I forget what the resolution is, but it is kind of high. That I think will trigger the course thing. RGB median, I can't remember what the color scale should be. Default's fine. Pick the blue band. Let's just look at a preview. Hey, I didn't practice a bit. Oh, that is coming. Yeah, so color map's probably not, color scale is probably not the best here. So let's see, let's click 50. But anyway, this is some fairly high resolution data set, and to render these tiles at the back end, I'm pretty sure we are like coarsening it. And then I can't remember what my benchmark numbers were, but I think we went like a 4 to 5x improvement on whatever those benchmark data sets were, right? So the scale of the improvement obviously is going to depend on the data that's underlying it. I think this is maybe 30 meters grid spacing, so it can take a bit of a while to show up, but yeah. On the previous WMS service, this kind of thing would just like take ages. And so now we can get to these tiles in kind of order of seconds, and we have some ideas for how to do this even better and faster. But anyway, hopefully that answers the question. The open source project comes with a little benchmark suite that you can run kind of locally, and so you can use that to check how fast those improvements were. And I think we maybe have some numbers in the blog post, but I can't remember now. Hopefully that answers your question, Hans. Yeah. I mean, the other thing that we do, you know, we're not going to reduce a terabyte of data to give you one small tile, right? Like that's just silly. And so at some point we need to build support for overviews. But the way we handle that kind of thing today is being very clear what we can do. And so the metadata that the tile service returns will also give you something known as a min zoom level that we can support. And so let's see, I think if I click download, yeah, so it'll tell you, yeah, so for this Sentinel data cube, it says the min zoom that we will respond to is 6. So that's, you know, somewhat zoomed in, but so if you send me a request at zoom level 4, you will just say, no, we can't do that because it would take too long. It would require us to load too much data. No, thank you. The minimum you can ask is 6 or anything that's more zoomed in than that. And so that's, when we eventually add support for overviews, that's something that we expect will just go away, right? Or, you know, depending on which overviews you have, maybe it just moves this number down a couple, or, you know, it's down to 3 next. So that's our kind of approach to that, is to just be very clear what we can and cannot do. So you kind of know what you're getting rather than just sitting there with a spinner waiting for things to happen. I think we've gone 2 minutes over time. So unless people have more questions, perhaps this is a good time to close.